Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about uniform distribution. The simplest example of a random variable of continuous type is a random variable with a uniform distribution. So this uniform distribution is also called as rectangular distribution. A random variable X is said to be uniform random variable over the interval a comma b if its probability density function is constant over the interval and that interval a comma b. So mathematically, the probability density function of the continuous uniform distribution function is given by or defined as small fx of x, and probability density function is denoted by small f. The suffix capital X is the random variable, uniform random variable capital X, and this x is the value of the random variable. So for continuous, the probability density function of the continuous uniform distribution is given by fx of x is equal to k over the interval a comma b and fx of x is equal to 0 otherwise. Otherwise mean x less than a and x greater than b, the density function is 0. So from this graphical representation, we can observe that the definition of the uniform probability density function. So x-axis is values of the random variable. Now here what is the range of the x? The range of the interval a comma b, and y-axis probability density function. Okay, and a less than 0, the probability density function is 0, and b greater than 0, the probability density function is 0. And between a to b, it has some constant value. It has some constant value k. So now determine that constant value k. So we know that the total probability is always unity. So that is the area under the probability density function curve should be 1. So that is integral minus infinity to infinity probability density function into dx is equal to 1. So what is the definition of the probability density function? The probability density function is a constant over the interval a to b. So using the definition, applying the definition into this area under the curve equation, we get now here what is the range of the interval a to b. So in that interval, the probability density function is constant k. So integral a to b k dx is equal to 1. So k is the constant that is written before integration. So integral 1 dx is x over a to b, and after that applying upper value and lower value of x, we get k into b minus a is equal to RHS term. So this b minus a is going to the RHS side. We get the constant k is equal to 1 by b minus a, and substitute this k value into definition of the probability density function in this equation. We get the probability density function of the uniform distribution as fx of x is equal 1 by b minus a for the interval a to b, and otherwise density function is 0. Okay, so this mathematical definition we can observe on this graphical representation. So this is the graphical representation of the probability density function. So next find out the probability distribution function or cumulative distribution function of uniform distribution. So we know that the density function is the derivative of the distribution function, and the distribution function is the integral of the density function. So the distribution function is equal to probability of x less than or equal to x. So this x is the random variable, uniform random variable, and this x is the value of the random variable. Now here x less than or equal to x mean the range of the x is varies from minus infinity to x into probability density function to dx. But what is the probability density function value? The probability density function value is 1 by b minus a over the interval a to b. So now applying the probability density function value into here, we get the distribution function is equal integral the fx of x is equal to 1 by b minus a. So when you applying this definition here 1 by b minus a in the range of the interval starting from a. So integral a to x final value is x, a to x dx. The starting of the density function value is a. So a to x. So 1 by b minus a is constant, that is written in before integration. Integral 1 dx is x over a to x. Now applying the upper value and lower value of x, we get the distribution function is equal 1 by b minus a into x minus a. So this is the equation of the probability distribution function or cumulative distribution function of uniform distribution over the interval a to b. So this is the concept of uniform distribution.